Hi, everyone. Good afternoon or good morning, good evening, wherever you are. Thank you for joining us today for our new edition of the Continuous Testing Meetup. Let's get started with the intro that we do usually. First of all, as we usually mention, have a look at our website, continuoustestingmeetup.com. You will be able to see all the future events and the previous events as well, like the one that we did last week about GitHub Actions. So if you missed that one, you can go and see the description over there, check everything that Aaron spoke about, and you can also obviously see the video over there. So don't forget, all the links are there for the different meetups, for our Twitter account, and our Slack workspace. We mentioned this last week, but it doesn't hurt to say it again. We are very happy in the Continuous Testing Meetup team that we have a new group in Barcelona. I met the previous owners of the meetup group, the Bugbusters group, and they were not able to continue with the group. So we had a conversation where they let us control the group, and they let us continue spreading the word about testing and good practices and basically do more things for the community. So as soon as it's allowed and safe to do in-person events again in Barcelona, we will go over there and we will do more meetups. So right now we are 3 groups. Maybe we will be more in the future. We don't really know. We don't have big plans. We just want to build a warm and happy community. So these are the 3 groups we have right now. Thank you to the sponsors of the Continuous Testing Meetup, Sauce Labs and Trendic. Thanks to them, we are able to actually do everything we can, like maintain the website, have time to do these meetups for you, for the community. So if you have any suggestions, comments, please feel free to reach to us in the Slack channel or just send us an email to our meetup group. So without delaying it more, today we're going to have exciting talk about contract testing, which is a topic that we haven't touched so much in this group. We have been focusing a lot in UI testing, so the higher level of testing. But I think it's pretty important to cover this topic as well, because in many cases, we don't really check, or we don't have good tools to verify the contracts between front end and back end, and between different elements of the back end as well. So without delaying the talk anymore, thank you, Thomas, for being here. I won't make a big introduction because I think you can do it yourself, but yeah. Truly, thank you. And please, the stage is yours. Thank you.
Okay, great. Thank you. So can everyone see my screen? We good?
Not yet.
Okay, let's make sure that happens. I went to the talk and I forgot to share my screen and it was really awkward. Cool, can everyone see my screen now? Great.
Yep.
Okay, so let me just move you all around. There we go. So yes, my name is Thomas Shipley. I'm currently a senior QA consultant for Equal Experts in the UK. At the moment, I'm working with John Lewis. And today I want to talk to you a little bit about relationships and how we verify them between microservices. And I wanted to start off with a question. So why is it that social networks are so valuable to both the owners of those networks, but also other people involved like advertisers? And it's the relationships. So if we think about a social network, we have lots of people involved, and those individuals have some basic information that is valuable, such as their name or their date of birth. But actually, advertisers and owners of social networks are more interested in the connections you make with other users. So your friendship groups or your local community, and also with brands. So it's the relationships that are really giving that network, that social network, its value. And so I wanted to ask a similar question about microservices, and you can kind of see where I'm going with this, hopefully. There is relationships that are most important with microservices as well. If we think about microservices, we may have multiple services that do various things on their own in isolation. So for example, an e-commerce website, maybe Amazon, might have an account service, a basket service, a stock service. Those all provide some value, but until they come together and form relationships, we don't have a system that's providing us some good business value, and it doesn't work. So relationships are more important than microservices themselves. And I think sometimes when we talk about testing microservices, we focus more on the services than the relationships they form. So we focus on performance testing or functional tests or security tests, but we tend to think a little less about how we're going to test the communication pathways between these services, the relationships. And so we're not very good at testing relationships generally, and this is something that I've certainly found and with teams I've worked with in the past. So let's dig in a little bit into how we might test relationships and why the current approaches are not so great. So straight from the beginning, we have two big options. We have end-to-end testing and we have integration testing. And hopefully you've seen these sort of styles before, they're quite common. End-to-end test is pretty much what it says on the tin. We're going to test everything all at once and from end to end, either on an environment that's some test environment somewhere maybe, or an environment that's spun up on demand. And then the same for integration testing, apart from we're just going to test a slice. So instead of testing everything, we're going to test maybe 5 or 10 services altogether and then stub out, mock out the rest and build our own little picture. And that's probably going to happen on a more in-demand sort of scenario, an in-demand environment, rather than a long-running one. But it could happen there as well. So both of these approaches are slow. They're slow because they rely upon these long-running environments or these on-demand environments. And they're also slow just because of the nature of this style of test. If it's end-to-end, we're having to go through an entire user journey, maybe via the front end, or even just via the services themselves, via RESTful calls. And if it's integration, it's still slow because while it might be a bit quicker because we're only testing so many things, we're still testing lots of things all at once. And when we test lots of things all at once, that makes our test brittle. So if we think about some good concepts for testing, we tend to want to try and test things in isolation. That's the best way to test things, because we know if we test things in isolation, if things fail, it's going to be that thing, hopefully. It's unlikely to be other things. And so with these styles of testing, we're not doing that. We're testing multiple things at once, and that makes them broad and it makes them brittle. And then also the reliance upon these external environments or even internal environments, which are long running, can also contribute to that. And because of all these things, they're expensive to run. So you spend a lot of time diagnosing these tests. So figuring out when the tests fail, why did they fail? What was the relationship that failed or the service that failed? If it's end-to-end, you've got maybe hundreds of services to pick from or tens of services. If it's integration, okay, it's a cut down number, but still a lot to investigate. And also the maintenance of these tests can become a real problem over time because you're having to maintain those environments and those tests and test multiple things all at once. It gets really costly. So what about mocking? When I talk to teams, sometimes they talk about mocking as a way to solve this problem. We can mock out all these other services, and that way we can test things quickly without these environments. But mocks remove relationships, they don't test them. If you think about what a mock is, and certainly the way I typically write a mock type test, is I make a call to the API that I want to mock, the service, and I get the response back. I take that response and I copy it into my test, into the text file or wherever it needs to live. And then I never check that mock again. I just let that mock continue doing what it's doing and let my test continue running. And some people who are perhaps a bit more on the ball than me might actually check that mock, but most people I think probably don't. They just copy it in. And when the test fails, they have to go into that test and they have to decide, was it down to the mocking that I set up? Or was it down to the test itself? And was there a problem there? So mocks remove relationships. They don't test relationships. They get rid of them from your testing. They also go out of date for the reason that I mentioned, because I'm copying it from somewhere and I'm never really checking it again, unless I go away and I find a failing test and I wonder if that's the reason. But also more worryingly than that, the test can continue to pass even when the relationship changes. So that service could change its relationship with you, with how it works, maybe introduce a new query parameter that's mandatory that you didn't know about, but your test will still pass. As far as your test is concerned, that mock is still valid. So mocks are a useless way of testing relationships. So what about contract tests? So if you think about the typical type of contract tests that some of you might be familiar with, they're quite circular in nature. So if we think about how a contract test is normally written, a team develops an API, let's say a stock API, and they make assumptions about how their API is going to be used. They then write a contract test that codifies those assumptions. And then that test runs and it verifies their assumptions. So it's very circular in its nature. Now that is useful. It's useful when we want to maintain versions of an API internally and we want to know if we've broken the version internally to ourselves. But at no point did we take consumer feedback in that loop. At no point did we go to our consumers and say, how do you actually use our API? We just put in our own assumptions, which may be right and they might be wrong. So contract tests in their traditional sense, the one that you might have seen before, are circular and they don't look at relationships, which is exactly what that slide said. I got ahead of myself. So consumer-driven contract tests fix these problems. And they do it for the key reason that they're consumer-driven. We're not making our own assumptions and proving our own. We're not having to rely on some circular test logic. We're taking in consumer feedback. And they test relationships. And they do it in a way that's fast to begin with. So one thing that we'll look at in a minute when I talk about how this style of testing works is that these tests ultimately are just 2 unit tests and a mock server. Unit tests are fast, mocks are fast. So these tests themselves are actually normally very quick to run. They're also very robust and tightly scoped. We're not relying upon some environment somewhere that needs to be running and stable. And we're only testing one relationship at a time. We're not testing many relationships all at once. We're just testing one. So when things go wrong, we know probably that it's that relationship that went wrong and it's not some flaky environment or some cascading failure. And because of all these things, they're cheap. They're fast and they're easy to diagnose and that makes them cheap. And finally, they're not circular. They're taking in your consumer's feedback, which is what makes them powerful. So if we think a little bit about how this style of testing works, let's imagine an example where we have a provider and the provider owns a stock API and you can make calls to that API to get stock information. And you have a consumer and that consumer is an Android team. They're writing an Android app that's the front end for that e-commerce website. And you can go into that app and you can buy things and that app makes calls to this stock API. And they want to test the relationship between them and the stock API, the provider. So the consumer writes a test. And this is a unit test. And this unit test is probably not all that unfamiliar to types of unit tests you might have seen before. They have this unit test, they have a mock server in the test, and they use that mock server to mock out, to stub out calls to this stock API. And they keep doing what they're doing and they test their functionality and their test passes or fails and they keep iterating around. But the key difference and what makes this a consumer-driven contract test rather than just a mocked out unit test is at the end of that test run, the consumer is going to generate a contract file. And you can think of this contract file like a forensic log. This contract file is going to contain all the information about what happened during that test. It's going to say the requests that were made to the stock API, how they were mocked out, what the responses looked like on the way back from the mock. It's going to say about the response codes that were expected. And it's going to list them down in scenarios. So if I were to go through this contract file, I can see exactly how this test played out. The team might have made 5 calls and got 5 responses, all 200 codes. It's going to be in the contract file. They may have also made a call that's a 404. It's going to be in the contract file. And so the provider, they can read that contract file. They can take it into their own unit test. And now they can run their own unit test against their own test environment or against production, up to them. But they can start to replay this contract file against their actual environment. So they can go down the contract file and see that, yes, this Android team made a call to our API for this stock information. Let's make the request to our own API. and then get the actual response back, and then compare. They can compare the mocked out response that the Android team set out in their consumer side test with the actual response, and they can check that they match up. And if they don't match up, the test will fail. So if they've got this set up in their pipeline somewhere, maybe in GitLab or in GitHub or any of these sort of CI/CD pipeline systems, their pipeline's going to fail. They're going to have a failing unit test. And they're going to have to go back to that consumer team, and they're going to have to figure out what went wrong. How are you mocking out our service? Was it a way that we didn't expect? Is it a way that we're not going to support? Or did we not tell you about something? So, for example, one of the things that came up recently when we've been doing this style of testing on projects I work on is my team introduced an API key. So if you called our stock service, you needed this API key in order to be validated. But we didn't tell anyone about it. We didn't tell any of our consumers about it. And then all of a sudden, all our contract tests were failing, all our consumer-driven contract tests. And consumers were asking us, what have we done? What did we do that you didn't expect us to do? And it's because we didn't tell them they need to validate. Otherwise, we're not going to give them information anymore. So that's the sort of thing that's really easily picked up by this style of test. And importantly, consumer-driven teams talk to each other. That's the whole point of this testing. So it's going to encourage you to talk to your consumers and get feedback about how they use your API. Or if you're a consumer, it's going to encourage you to talk to your dependencies, the APIs that you call within a system. So how could you maybe start using this style of testing, this consumer-driven contract testing? So the tool I've been using with teams is called Pact. There are other tools such as Postman, I think now supports this style of testing, but I've been using Pact. And the reasons I like it is because it's open source. You can go to GitHub and you can look at how this framework works, and you can dig into the code. Another really powerful feature of Pact is that it supports many different languages. So if we think back to the example, and one of the things you might have been thinking of when I talked through it, is what if these teams are working in different languages? What if these teams are working on different stacks? That Android team is probably working with Kotlin, but the backend team could be working with anything. They could be working with Java, C#, Go, who knows? The great thing about Pact is that you're just passing around a contract file. It's just a blob of JSON. And each team can write their test in any language they see fit because there's supported languages across the board. It supports Ruby and JVM and .NET. So just because that Android team is using Kotlin and the other team might be using something else, you can still use this technique. One thing to note as you go through the documentation, in fact, is that contract files are called Pact files. That's the only real difference to the example I just showed you. Otherwise, it works in the exact same way. Another reason I like Pact, which we'll dig into, is that it provides a service called the Pact Broker. Now, this is a service that you'll have to host yourself, but you can also use the commercially available hosted version called Pactflow, which is maintained by the core team. But the Pact Broker is going to enable you to share these Pact files really easily between teams, because one of the things you might have also been thinking about is, okay, how can I pass these contract files around? Because now these teams need to pass these files to each other. And that's something that the Pact Broker can help with. So let's dig a little bit into how we share these Pact files. So you have three options for how you might do this. The first one is the file system, which is really easy to set up. If you've got all these services that you want to test all hosted on one machine, then this could be the easiest option for you to do. You could just set up a folder on that machine and just put all the Pact files in that folder. But it's not very scalable. Most of these distributed systems that we now talk about when we're talking about a microservice architecture are distributed. And so many different teams are working on all these different services and they're hosted all over the place. Maybe they're hosted in a cloud service, for example. So it's not very scalable. And you could try and get around that by saying, let's check it in as a Git repository somewhere, but you'll quickly find that that becomes a problem. And you also don't get an overview. So one of the things that I'll talk about when I talk about the Pact Broker is you start to get this really good visualization of all these relationships. Another option could be a bucket. So a bucket is really easy to set up. You can just go to your cloud provider of choice, go set up a bucket, tell people to put their files in there. And that's dead simple, and it kind of scales, because now we can put protections in for overwriting each other's files. It's in a cloud hosted space that everyone can get to. We can set up some authentication. That kind of scales, but we still don't get this overview of all the relationships that make up our system. And that's a really valuable thing that we also want to get out of this if we can. And that's why I prefer, and I would recommend for most teams, to look at the broker. So the broker is a bit more set up. This is something that you're going to have to host yourself or run internally. Now the core team do provide a Docker image that can make this easier. But even so, you're going to have to host it, maybe using Docker in a cloud service somewhere or on a virtual machine. But the benefits are really powerful. So it's scalable. So now you're going to get a RESTful API that you can call to push Pact files up to the broker to be versioned and maintained. You also get an overview of the relationships that make up your system. And you also get some automatically generated documentation based on that Pact file. So that's really useful, not just for technical people in the team, because they can see the very technical detail of the mocks. It's really useful for the non-technical people in the team. So if you're a product owner and you want to know who's consuming the service that your team provides, you can go to the broker and look at the automatic documentation and see all the different consumers that are using that API. So that becomes really powerful as well. And then finally, you get webhook support. So if you wanted to start integrating this style of testing to your pipeline or to Slack, the broker makes that really easy. You can set things up, for example, like I have, where you can say a consumer has pushed up a new contract file. I'll just start my pipeline as soon as I get that webhook event. So I can test and verify that contract file in my provider side test. You can also do things like integrate it with Slack. So you can message team channels when a verification on the provider side fails. Both sides of the relationship as well. We can message both team channels or a combined team channel if that's how you've got it set up. So here's a couple of screenshots that I just took from the Pact broker documentation. The examples are not the most inventive in the world, but bear with me. So on the left, we have this network diagram where we have all these different services, and we can see how these services are starting to communicate with each other. We can start to build out that picture. So if we have lots of people using this style of testing, we can start to get a self-updating, accurate picture of our service and how our service fits in with the entire system. So that is really useful. And then on the right, we also have the auto-generated documentation. So in this example, we have a zoo app and an animal service, Android and some other backend team. And you can see exactly the type of requests that they make during their test. You can see that they make requests for an alligator, and there should be one named Mary and all this sort of thing. It's a sort of noddy example, but you get the idea. You get this generated documentation, which is really powerful and a great way to show particularly non-technical members of your team the relationships that are forming, so they can go away and speak to product owners of other teams. So I wanted to talk a little bit about my experiences of using this tool before hopefully taking some questions. So on the good side, there's no environment orchestration. So I'm not relying upon this long living environment that it's been patched how many different ways. It's got this script that keeps it going. It's got some security vulnerability because someone didn't keep the OS up to date, whatever it is. I'm not relying on any of that anymore. This is a distributed way of testing. We are sharing Pact files with each other, and we're not relying upon these big end-to-end environments. And we don't get slow and brittle tests. So the testing on either side of that relationship is fast because we just have 2 unit tests. The consumer has a mock server, but that's fast as well. And the tests aren't brittle because we're only testing one relationship at a time. We're not testing the whole system. We're not testing a subset of the system. We're just testing the relationship between one team and another team, the consumer and the provider. And if these tests fail, it's probably an issue for that reason. There's nothing else that can really go wrong with these tests. The tests fail, you've probably got a problem with your relationship. And that means you need to go and speak to the consumer if you're the provider. Or if you're the consumer, the provider is going to come and speak to you because you're now blocking their pipeline with this failing test. So they're going to want to speak to you very soon. But there are some drawbacks. There are some things that might block you when trying to implement this style of testing. So the first one's a network effect problem. As you could see from the screenshots when they talked about the Pact broker, the real power in using this technique is when lots of teams buy into it and lots of teams want to do it. You can't use this technique on your own unless you happen to own all the services in your system, in which case go ahead. So you need to get buy-in, and that can be quite tough. There's also a learning curve. So when we talk about contract testing, most people think of that circular example I showed you, which is good for checking versions of APIs, but it doesn't test relationships. This is consumer-driven contract testing, and it's a different style of thing, and it'll take people a little bit of time to get to speed with. It's definitely worth doing. And then the other big drawback, which isn't really a drawback, but it's definitely one that you're going to have to discuss with your teams, is another team can break your pipeline if you're the provider. So if you're the person providing this API that's being consumed by someone else and you're pulling in these contract files, Pact files to be verified as part of your unit test, well, the consumer could put a mock in their test on their side, which doesn't make any sense, something you're never going to support. But now your pipeline is failing. And the only way you can fix that is by going to the consumer and talking to them about it and getting them to update their test. Now, as you can imagine, you might get some pushback from some people in your team, but remember, this is actually a really good positive thing. So if we think about the example I gave just at the start of this talk, I said we didn't tell anyone about requiring an API key to authenticate for our service. These consumers blocked our pipeline. That was good. We didn't break the relationship with all these different consumers. So it's actually a really positive thing, but it will take you time to sell that to your team, because if you're the provider, you don't want to rely on another team to get your pipeline unblocked. But on a positive note, it normally isn't too difficult to fix these things once you've had a conversation. So to wrap up, and then hopefully take some questions. Relationships are more important than microservices. When we talk about testing microservices, we often talk about testing the services themselves, and we talk less about how we're going to test the services and how they communicate to each other. So test the relationships. When we're talking about a microservice architecture, it's the relationships which are the most important thing and the thing that will often fail. So test your relationships and talk to each other. The only way you can do this style of testing, and the only way you can test those relationships at all, is if you speak to each other. Any questions?
Awesome, thank you very much. So if anyone has any question, you can just unmute yourself and ask directly, or if you are in a loud environment or don't want to ask, just write it in the text and I will read it out loud. And if nobody has a question, I have one. Huh? Okay, if no one unmutes themselves, I will just ask. So the broker, where does it live? Is it a constant thing? Is it like constantly running in the background, or is it only when you actually run your pipeline, is it spun up as part of your pipeline and then shut down again?
So this is a constant thing. It's basically a microservice in itself. This is a service that you'll have to host somewhere, and it handles the exchange of contract files between teams and also integration with other things like, you know, your pipeline, Slack, whatever else you want to integrate with.
Okay, thank you. Okay, there is a question from Amal. He or she asked, does GraphQL make any difference in CDC approach?
No, so I've had this question, I think, on every single occasion I've given this talk. So it's a popular question. You can use this for a lot of different communication pathways, not just HTTP. You can use it for GraphQL. One team that I'm currently working with and speaking to are using it for PubSub in Google Cloud Platform. So you're not just limited to HTTP, you can absolutely use this for GraphQL. And my own team use it for GraphQL.
Mm-hmm. Okay.
Hi, Tom. Thanks for the presentation. Hi. Really useful content there. My name's Dan. I was just hoping to be able to answer a question around the broker and how well that scales. Mm-hmm. So obviously you mentioned it's a point for exchanging contracts, but is there a point at which, say, if you've got a lot of microservices and a large distributed architecture, you might recommend having different instances of the broker if there was a clear segregation of services that never talk to one another? Or is it something that fully scales and you should just put all of your packs in that one location?
So I've not experienced a slowdown, but then I've not run it with many hundreds of services as of yet, because as I sort of talked about before, there's a bit of a sales process involved in getting teams on board, and that does take time. But it's a very lightweight service. So all this service really does is it takes in a post request with a file, a data object, and it just inserts that into a database. But there's nothing stopping you if you're worried about performance of the broker, perhaps it's starting to slow down. There would be nothing stopping you from, say, running up multiple instances of the API and just having it share a data backend. You could potentially do that. So if you're using the likes of Kubernetes, that would be pretty straightforward. You know, you could just have multiple pods and just round robin, that sort of thing. But in my experience so far, it's pretty scalable.
Thanks, Tom.
No worries.
Okay, here's another question from Mario. Can you give some concrete examples of a test? Are you checking business logic from the consumer point of view, or are you testing more focused on, e.g., HTTP codes, if mandatory attributes are filed and things like that?
So the best way to do this style of testing is to test from the consumer's point of view. That's the whole point of this style of testing. It's consumer driven. So as an example, if we think again about that Kotlin example I was talking about, where you have an Android team and they make calls to a stock API to get information, that Android team would have their unit test, their consumer side test, and they would make calls, mocked out calls to the stock API, but they would only mock out the things they use. So they wouldn't mock out the entire API. They'd just mock out the key fields that they use that they want to test, and then that would get passed over to the provider side to validate. So the stock team would have their unit test, they'd run it, they'd call against the actual service, get actual responses back, check that they match up. In fact, it's probably a bad idea to try and verify everything. I wouldn't do that. Because if you try and verify everything as a consumer, you're going to block a lot of providers' pipelines very quickly, because they might change things that you don't care about, and your contract file will break it because you don't care about it, you don't have any interest. And then they'll come and speak to you and say, you're blocking our pipeline. What are you doing? You know, are you using these fields? And you go, no. That's not a great experience. So only test the things you use as a consumer. And yes, it's very consumer driven.
Thank you, awesome. The next question is from Clyde. And he asked, as a producer service, which has other dependencies, should I mock my dependencies out when executing my consumer contract tests?
Yes, so if you think about how it works, we are testing one relationship at a time between a consumer and a provider, and that consumer is submitting a contract file, a Pact file, which is read and validated, and that's how that works. Now, if you're a provider, there's nothing stopping you from also being a consumer. So you could have two tests. You could have your provider test, which you use to validate interactions with your consumers, and typically you would only have one provider test to do that. But you might also have multiple consumer tests of your own, where you're generating your own Pact files to pass on to the providers that you use. So it basically works in the same way, and you can absolutely be both sides of the relationship at the same time.
Okay, thank you, awesome. So basically, if I understand it correctly, it's kind of, you're still kind of making like an end-to-end kind of scenario, but you're making it asynchronous, and you can just
exactly
take something from the front and be still sure that whatever is behind you is still working. It's interesting.
Yeah, absolutely. But you're also only doing it at one relationship at a time, right? So you're not testing all
Very
the
cool.
things all at once, and you're doing it in this asynchronous sort of way. So you're not relying on an environment or multiple teams to be available.
Okay, awesome. I think, Stephen, you unmuted yourself. You want to say something?
Oh, sorry.
No, I guess not. Okay, then we have one last question.
Cool.
How does API versioning and in CDC play together? Do we then version the contracts as well?
Yes, yeah, it's something I've not touched on in the slides, which maybe I'll sneak in after this. So the Pact broker at least, and you can do it in other ways, but again, the broker's really good for this stuff. Supports versioning. So you can submit your Pact file as a consumer and say, I'm submitting this Pact file and it's from this version of our build. So in the examples I've worked on in the past, we use the git commit char, the short char, that's our version. And we just say that's the version of the consumer contract. So you can absolutely version it from that side. And then on the other side, on the provider side, they can do the same thing. So they can say, we verified it against this version. And again, you could pass up the git short char. That's probably a good thing to use if you're using git. If you're not using git, then maybe use something else. And then the other nice thing you get from Pact, and I don't think this, I'm not sure if this is managed by the broker or the individual libraries. I think it's managed by the broker, is you get pre-validation. So the broker knows all your different versions of your consumer side Pact file, and it knows all the different ways it's been validated against the provider and the changes on the provider side. If it sees that there's no change on either side of that relationship, it will pre-validate that file. So you instantly get a validated result. So it only actually runs the provider test when it needs to.
Yeah, awesome. Makes sense. Yeah. Would you say this is something that only really makes sense in a microservices environment where you have a ton of small things communicating, or is this also something you could implement if you have like your monolith and let's say a couple of extra communication or services that have to be validated?
So I think it does depend on the context. So this is really well suited to a microservice architecture because you have lots of communication pathways. And actually, when you think about how you might test that style of architecture, testing them becomes even more important sometimes than testing the individual nodes. But if you do have a monolith and you just have a couple of relationships, then it kind of depends on how much pain your end-to-end tests that you currently use to test that, or your integration tests that you currently use to test that, are causing you. If they're causing you a lot of pain, then yeah, I would definitely look at this as a way to get around that. But if not, then maybe you can just stick with that and you'll be okay. Another question that I've been asked before is, what if you have third-party providers? Does this work with them? And yes, it absolutely does, but remember you need to have buy-in from both sides of the relationship. So in those cases, sometimes you might be better off with a sort of more traditional integration or end-to-end test.
Okay, awesome, thank you. If no one has other question, Diego, do you want to take over? Oh yeah, sure.
I actually have a question because in a previous company, we tried to work on the contract testing topic, but something like two things were really complicated. So I wonder how you're tackling that. The first one is how do you convince people to do this? Because you need actually the person who is writing the microservice to buy in. Mm-hmm. And the second one, something that we never thought about, I don't know if you have thought about that. It's like when someone breaks the contract, do you have like an SLA to repair it or something like that?
Yeah, sure. So if we go for the first question, because that's probably the most complicated anyway, like how do you get people to do this? So that is hard. I've tried to do it in different organizations and it's not always worked because I've not been able to get buy-in. If you can't get buy-in from a couple of different teams, then yes, this is going to be difficult. The way I was successful with doing this at my current project is by basically I was the provider. So I looked at all the different consumers of our API and all the different teams that manage those relationships. I sort of just focused in on the team that I thought would be most sort of accepting of this style of test. Right? The team that would be most on board with it, they like to test their stuff, maybe I can convince them. And we just worked together because we had a good relationship anyway, and we worked together on a really small proof of concept. Just one consumer test, we set up a broker dead quickly using the Docker container, off we went. And then we just started demoing it. So it did take a bit of a sales pitch style thing. So if that's something that you're not comfortable with, then chances are you're going to have a bit more of a difficult time doing this, or you at least need to find someone to help with that. But yeah, we demoed it internally at internal QA community events, and we went about it that way. You still get some teams that still don't want to do it. All I can say is that's just down to persistence. So when we talk about, for example, the Android team in my made up examples that weren't quite made up, the Android team really didn't want to do this at all. They were an offshore team. They were judged by features delivered, not necessarily by the reliability of the features delivered, which is fine. That's just the metrics that were set up by the business. That's not their fault, but it does mean they're working in that environment. So it did take a bit more of a sales, and what I ended up doing was just sitting with them for a day to write that test, and it didn't take too long. The second bit of your question, which I'm rapidly forgetting, so you're going to have to remind me.
Yeah, the second one was because we had a couple of situations where actually the provider broke the contract,
Yes.
and that was found by a consumer, and then there was no really like an SLA. So when are you going to fix?
Yeah, sure. So yes, I kind of come across this problem, but I guess I've been fortunate in my current project that it's not been such a big deal. So we've set up a Slack channel internally where we can just talk generally about Pact testing. And then we've also set up integrations with Slack to message consumer teams when they do break provider pipelines, and also the provider involved. And then we say, for example, if it was a relationship that I'm involved in managing, I would also message maybe that team channel and get some feedback quite quickly that way. There's no formal SLAs that we've set up. Maybe that's something that some teams would need to do, but I think the more you use this style of testing and the more successful you are with it, you realize a couple of things. The first, that as a consumer, it's normally quite a quick thing to fix a test. It's not that difficult. It's just a mock type test. You just change the mock. It's not a big deal in most cases. And also, as you use this style of testing, you find that it also helps develop just the person-to-person relationship. You get to know people's names, you get to know teams better because they're breaking your pipeline and you're going to speak to them about changes you're making and so on. And it encourages conversation. And that's definitely one of the things that you would hope to get out of this. So I've not needed a strict SLA yet, but maybe in the future as things get bigger, I might have to wave a big stick at people.
Great, thank you. I think that was clear for me, and I hope that was clear for many of you. So thank you, Thomas. It was very, very illustrative, and it's nice to have someone who speaks about a topic that has experience in, and that's one of the key things that we are looking here, and to share this knowledge in the community. So really, again, thank you for taking the time, and this means a lot to us. Thank you.
Cheers, brilliant. Thank you very much.
Thank you. It's really cool. It's a new topic for me, and I will definitely check it out a little bit deeper. Very cool stuff.
Yeah, definitely. Let me know if you have any success with it. I'd be really interested.
Right, so I'm taking over the screen share. I think you can see now Thomas again. So for the 10th time, thank you. So we're gonna cut it short today, but because it was like a really good presentation to the point, and there was like tons of questions. It was very, very dynamic, and that's kind of the type of meetup we're looking for. So before announcing the next one, we sent maybe a couple of hours ago a message to you through meetup.com, because we would like to learn more if like what day of the week and what time during the day works better for you to do the meetup. Right now, we're mostly doing them either on a Tuesday or on a Thursday, 5 in the afternoon, Berlin time, but maybe a different hour will work better for you all. So please check your inbox, and it takes like 15 seconds to click a few check boxes and click on submit. So that's it. And thank you, Severin, for having the Q&A. That was very swift and straightforward. Thank you. And let's announce the next meetup. So on September 3rd, we are going to have Sophia, the director, board member from Abstracta, but importantly, co-founder and CEO of UpTeam. This is a company who is working a lot with performance testing, and she's going to tell us a lot of the knowledge and theory behind performance testing for mobile applications. So it's a very rich session about how to approach this problem, different approaches, different solutions that you can take. So I hope that you can join us in a couple of weeks. And that's it for me today. Again, thank you to everyone. Thank you, Thomas. Thank you, Severin. That's all for today. Thank you very much. Bye.
Yes, thank you. Bye.
Bye.